work some problems to cement some of uh, the characteristics of functions that we talked about in the last video. Here's a problem um, given here. Let's say I'm going to give you a problem. Oops. Uh, Here's the function, and I'm going to give it to you algebraically. I guess if I give you a graphical function, you've learned how to graphically recognize if it's odd or even. But here's the function. They want to know, is it even, odd, or neither? Okay, so kind of the key is, well, what happens when you put in the negative value of x here? Let's see what happens. Well, if I put in the negative value of x, I get negative x. I get negative x squared plus 1. Well, okay, what's going to happen there? That's going to give, I get negative x on top. Now I know here this can be simplified, right? A negative x, if I square, it's just going to become x squared. X squared plus 1. And now I what? Well, how does that look like this? Is there any relationship to that? Oh, that looks like the following. That's negative x over x squared plus 1. Which is what? Well, that's just negative f at x. All right? So what is this? Now I just showed that f of minus x is equal to negative f of x. Graphically, just to let you know that, if I put in an x, if this is x, f of x, that's a point right there. Then if I put in the negative x here, that's equal to, this is negative x, I get what? I get negative. So I get that kind of look, and again, I might have something that looks like this. All right. So it is what? It's odd. Algebraically, I showed that was odd. All right, next problem. What do I got? Oh. Is it odd, even, or neither? Odd, even, or neither. That's the game. So we'll say, well, g of x is equal to x squared over x to the 4th plus 1. Well, that's a kind of a dead giveaway here. Notice these are all, we'll just change the color here. Notice these are all even powers, powers of 2, powers of 4, and you'll see what happens. What happens when I put in a negative x to those things? Well, let's see. G of minus x equals what? Well, I take minus x, that's the input to my function, and I plug it in. Well, that's just minus x squared over minus x to the 4th plus 1. Well, again, these are even powers, so what happens to minus x squared? Well, that becomes just x squared. What happens to minus x to the 4th? Well, it's the 4th power. So if you take minus 1 to an even power, it's going to be positive, so that's just going to be x to the 4th plus 1. Okay, so what's that, though? What's this? Oh, that looks like just g of x. So what did we just show? G of minus x for any x. I didn't just show it for a particular x. For any x, if I put in a minus x, I'm going to get the same value as if I put in a positive s. And that means this is an even function. And again, recognizing a function as an even or odd function can make the calculus easier. Finding integrals can be simplified. Sketching functions can be a lot easier too. I think by mistake I just did your homework problems, but here's one I wanted to do. Here's one I wanted to do actually. Here is just to introduce a different function. We got to get to that library function soon. But here's a function f of x going to be equal to x times the absolute value of x. Is it odd, even, or neither? Okay. First of all, do we know what the absolute value looks like? Let me just draw that. And this is, again, one you should be familiar with. If I put in an x, and this is the absolute value of x, I get something like this. Okay, that is clearly what type of function? Well, that's even. That's an even function, right? If I put in an x or a minus x, I get the same value. I get the same. These are equal. Okay, so absolute value, one of the things you should recognize. How about this function over here? Well, let's put in a negative value here. F of negative x is equal to negative x. I just plug it into the function, right? That's an input to the machine. I put in minus function here, and I put in minus x here. Can I simplify anything? Well, I get minus x. What happens when I take an absolute value of minus x? Well, I just get x back. It's even, right? If I put in minus x in here, I get the same thing as positive x. All right, now how does this compare with the positive value? Well, it looks like that's just equal to negative times the whole thing, x square root of x. That is just equal to f of x. So it's negative f of x. And that is what? What type of symmetry is that? Well, that is odd symmetry. Here's another problem I've picked to demonstrate a different kind of function here, this being a piecewise defined function. Notice we have a function of x is defined as a certain function when x is less than or equal to 1. Okay? And then when x is greater, or negative 1, when x is greater than negative 1, it's equal to x squared. The question is asking, find the domain and sketch. Okay, so we'll go over how to graph these things in your graphing calculator. But here's a piecewise defined function, and a lot of times there's some interesting things that happen right at the intersection of the two logical boundaries here. So as we look at this, let's draw it. Okay, so x is less than negative 1, and we see it's x plus 2. Well, let's see, x plus 2 be 1, 2, x plus 2. Go to like here. So I'm going to draw that like this. This is the x plus 2 side of things. I guess maybe I can change colors. Be professional here. This is x plus 2. What happens at negative 1? Well, at negative 1, this point right here, actually, let's just put the boundaries on it. At negative 1, this is equal to 1, which is what I wanted it to be. 1. At negative 1, it's equal to 1. Okay, and I guess that should be 1. It should be 2. Now at negative 1 here, this is equal to 1 also. That's good. And at 0, that's equal to 0. So this is just a parabola now. Okay? This is the x squared portion of it. So here is my, well, what's my domain? Domain is what? Well, there doesn't seem to be any limitation. X can go all the way out here. You know, the domain can all real numbers. So I'd say x is an element of real numbers. Oops. Of reals. Or you could say maybe between minus infinity and negative infinity. It could be written like that. What about the range? The range also. The range, if this is function, I could say the range f of x is the same thing, all reals. But why did I pick this problem? I wanted you to see what a piecewise function. Piecewise function. And again, there's no reason a piecewise function couldn't have 5 different steps, but between here it's this, and then it's this, and then it's this, and then it's this. So you've seen this before, but remember what a piecewise function is. Okay, see you soon.